The problem is the sine squared. If it were cosine squared, that would be better, because then we'd have all that stuff. Yes, I did. Thank you. We would have cosine squared. I mean, if it were cosine squared, then we'd have cosines everywhere, wouldn't we?
Yeah.
So this is really problematic. And I did see some of you saying, well, if that was plus 1, we have an identity, don't we? But it's not plus 1. You can't make this plus without making that minus. There's no way around it. But the identities are identities. You use them all throughout when you were doing your proof of identities, right? So can I actually solve this identity for sine squared theta? And if I solve it for sine squared theta, I'm left with 1 minus cosine squared theta, right? Yes? That means anywhere you see sine squared theta, you can replace it with 1 minus cosine squared theta. So why don't I just come back up here and replace that with 1 minus cosine squared theta. Then I have minus cosine squared theta equals 1 plus cosine theta. That is the exact same expression, isn't it?
So you can just take that.
Oh yeah, absolutely. You can replace just this piece, sine squared theta, with what it is. And that will switch it over to cosine squareds. Okay, now that you have that, you have a quadratic. This actually turns out to work out pretty clean here. So your approach was different, gets you to the same place. Good. Should I work through this, or I can put these two together? They're both negative, so I have -2 of them. And it's starting to look pretty quadratic here. Why don't I move everything to one side? And something nice happens when I subtract the 1. It goes away on both sides. And then I'm going to move that to the other side also. So I'll get 0 on the left. I'll get a +2 cosine squared theta, and then I had already there cosine theta. Now that's kind of quadratic, but it doesn't have 3 terms. It only has 2. So it's actually easier to solve than the previous one. If you just remember how to solve a quadratic that looks like this. Like if I give you a quadratic that looked like that didn't have a third constant in there, you would just do GCF here, wouldn't you? You'd factor an x out of both of these. So since these both have a cosine, you just factor a cosine out. Like that. That make sense? Now you can set each of these equal to 0. 2 different factors. So I'm going to set cosine theta to 0. And I'm going to set 2 cosine theta plus 1 equal to 0. Where are my dots on that first one? Straight up, right? And straight down. Pi/2 and 3pi/2. This one I haven't isolated, but this should turn out to be cosine theta is -1/2. That's going to be here and here. So how do I represent those general solutions on that first one?
It's pi over 2 plus 2 pi n.
Plus
I mean,
pi n, right? Because you can come right back to it. And then here, two separate ones, yep. 2 pi over 3, good. 2 pi n, got to get all the way back around to it. And then the other one, it's 4 pi over, no, hold on. I wrote it down wrong. It is 4 pi. I don't know why I wrote 5. 4 pi over 3 plus 2 pi n. I did make a mistake. That should be theta, not x. Theta. So what do y'all think? You think you want that on this test on Thursday?
Like extra credit.
No? You don't want it? Okay. I'll consider it as a bonus then. I'll do it as bonus. We're not done with this section. There's still more because we haven't solved any trig equations that involve tangent or cotangent or secant. But I think you kind of get the flavor here for what's going on, right? I don't think I want to add anything onto your plate today. I think we're good for now.
So what sections are going to be on this?
Yeah, let's talk about that now. All right, let's talk about the exam.
is it the one we did with all the groups on? Is that what you're looking for?
No, that was even.
All right, so what will it cover? Well, the last exam ended back with the unit circle approach to the trig functions. So we have 7.76, 7.7, 7.8. Let's talk about those first. This is all graphs of trig functions. That includes all that phase shift, period, amplitude, all that stuff, right? And then after that, 8.1, 8.2, 8.4. All right, so let's see. 8.1 was the inverse trig functions in arcsine, arccosine, arctangent. 8.2 was the rest of them, the rest of the inverse trigs. And then the 8-4 is the identities. So that's what it'll be on the test. I'll put 8-3 here as bonus. That's what we just talked about today. All right, so in terms of graphing trig functions, let's talk about what sort of problems you might see, all right? Something that I think is doable. So what I'm doing is I'm looking at the chapter review right now. It's on page 600 in the book. I'm just going to look right now and see which of these look like right off the bat look to me to be something that I would put on a test. And right away, this one right here looks pretty good. Y equals, I'm gonna just make one slight adjustment to it. 2 cosecant of x plus pi over 4. And I might be more inclined to put something in here like 4x plus pi over 4. So the instructions here are to sketch this. What I expect from you on the test is to see a bunch of work and then a picture, everything labeled, right? I only need you to do one period, but that means one very clearly labeled and detailed picture, all right? So let's go through this process. Do y'all want to do this? Yes? Okay. All right, so what would I do? First, change it over to what is it? Sine or cosine? Sine 4x plus pi over 4. All right. So I'm going to graph the sine function first. So how would I go about graphing this? Set the argument equal to 0. And I set the argument equal to 2 pi. And then I go and solve for x. So if I do this, 4x equals negative pi over 4, moving that over, and then divide, I get x is negative pi over 16. This one's a little more involved. X is equal to 2 pi, and I'm taking away pi over 4. So that means 4x is equal to, I could get a common denominator, a pi over 4 minus pi over 4, 7 pi over 4. So 4x is 7 pi over 4. And then again, I divide through by 4, and I get x is equal to 7 pi over 16. Okay, lead the way. What now? Draw a graph, number line, little number line, plot those. Yes. Question?
Are we still, like on the test, it's going to ask for the amplitude, the period?
Yeah, let's get to that after the graph. Let's get the graph up first, and then we can talk about all that other stuff. Okay, for this, I'm going to draw a number line. I'm going to put negative pi over 16 here. I'm going to put 7 pi over 16 here. Okay, now what? Find the middle. Find the middle of these. And to find the middle, add them up, divide by 2. So if you add those together, what do you get? 6 pi over 16? And then divide that by 2. Yeah, 6 pi over 32. So I add these two together first, and then I'll divide by 2. So 6 pi over 16 divided by 2, which is the same as 2 over 1. Flip it, 6 pi over 32. But you can reduce that fraction out. That's a 1. So that's 3 pi over 16. And then do the same thing to get the quarter marks, right? So what's the next one going to be? Should be pi over 16. That's what you should get for the next one. So I'm not going to do that one. And then this one should be 5 pi over 16. I want to see these on the test. I want to see that you can get the endpoints and the quarter marks, right? In the middle. Okay, now what? Mark the x-intercepts, right? And where do I mark them? Since it's a sine curve at the ends and in the middle, right? So at the ends and in the middle, I have x-intercepts. Okay, now what? Test point, right? I'm going to test one of these points. Which point should I test?
Pi over 16.
Pi over 16. Because these are x-intercepts. So I'm either going to plug in pi over 16 or 5 pi over 16, one of those. So let's do pi over 16. Where am I plugging that in? That one right here for x into this, right? Right there. So let's go ahead and do that. So we plug that in. We get y is equal to 2 sine of 4 times, I'm plugging in pi over 16, plus pi over 4. This is 2 sine of, isn't that pi over 4 right here? Mm-hmm. And then plus another pi over 4 is 2 pi over 4, which is pi over 2. And sine of pi over 2 is 1 times 2 is 2. So this should come out to be 2. Yes?
Do I have to put that, or can I just look at the 2 before the sine? Just put that on the graph?
You can do that at your own risk, because there is a way that I can make this problem work out where this is a positive 2, but that first point is actually going to be on the bottom. Basically, the graph would be over here somewhere. So it's dangerous to do it that way. So I would advise just plug it in. It takes 15 seconds more, 20 seconds more. Okay, so that means that at pi over 16, I'm up at 2, right? Now I never put my y-axis here, but my y-axis does go right about here, right? Because this is a negative number, that's a positive number. That's my y-axis. So this is 2 here. And that automatically forces 5 pi over 16 to have to be negative 2. And then I could draw my sine curve, right? But remember, this is not our final picture. So I'm dotting it. And now I'm ready to draw the cosecant function. Also, I did not have any vertical shifts on this, right? There was no like plus 2 or plus 5 here. This graph is not being moved up or down. If there was something out here, I would just draw this still, and then I'd just move it all up or move it all down. Okay, here comes my answer. My answer is going to be this one right here. So anywhere, well, no, you're supposed to tell me. Sorry. Wherever there's an intercept, draw a vertical asymptote. Yep. And finally, draw those little U's, right? And they have to start at the peaks and the valleys. So this, that, that, like that. Okay, now let's talk about all the other ancillary stuff that comes with this.
Wait, I have a question.
Yes?
So whenever you're doing your test point, if what you get in your argument isn't a common angle that you would know, do you know that you did something wrong? Like we don't
Oh, okay, yeah. So the question is, when you're plugging in this test point pi over 16, and you come in here and work it out, if this is not a common angle, there's something wrong. Yep, there's something wrong.
And if it doesn't make sense, like it's an undefined type thing, then you did something wrong, right? It should be
Yep,
one.
yep.
Okay.
You should get a nice number here. Because the way we got these points is by setting our argument equal to 0 and 2 pi, which means that we know these two are going to either give you 0 or 2 pi. And then these are going to be quarter marks of those. So if you think about 0 and 2 pi, you've basically quartered out. So you should land at one of those. Yeah. All right, now let's answer some other questions that I could ask pertaining to this same problem. I could ask you to find the domain. That's a hard, the domain is actually a hard one. Because this thing is not defined everywhere, right? Where is it? This was the problem I think I showed you in class that not everyone caught on to, and I don't think I'll ask you this on the test.
The domain?
The domain of this type of function. I can ask you the domain of a sine function because it's all real numbers. But for like a cosecant or a secant, do you remember it was like everything between negative pi over 16 and 3 pi over 16 and 3 pi over 16 to 7 pi over 16 and then I came up with a general way of doing that? Okay, so let's not worry about it. Because I want to talk about some other things here. Now, the range I will be able to ask you. What about the range of this function? Negative infinity, negative 2, bracket, union, to infinity. There you go. I will say on this one right here, maybe as a bonus, okay? I won't prompt you for it on the test. I won't tell you to give me the domain, but if you actually do give me the domain, I will give you a bonus for that.
What if you get it wrong? Do we get
I won't penalize you. Yeah, but don't like invest 15 minutes trying to get the domain. Okay, so yes, so far domain range, yes.
And so for the domain of this one, you would go from pi over 16 to 5 pi over 16 until you get the whole range of it?
No, the domain would include the whole domain, like on everything. Like you would have to include all the intervals.
What video did you?
I don't remember, but I did do it. I remember doing it.
I'm gonna have to look through.
You might have to go back and look at them when we were graphing the trig functions, because I did do it, and we just kind of found out like the distance between these two, and we used an n in there also. Yeah, go look at it. I'm not gonna go over it right now. Okay, domain and range. How about amplitude?
2.
Okay, so the amplitude is the absolute value of 2, which is 2. What next? Period. How do you get period? No, the period. What was the formula for period? 2 pi over.
The W.
You're thinking phase shift.
I have the notes written down where it says that. I thought the phase shift was theta over omega.
Okay.
And that gave us negative pi over 16.
So look, this is why I don't like formulas for phase shift and period, because people always forget them. Look at what is the distance between here and here? That's your period, isn't it? Okay. So how could I find the distance between those two?
You subtract one from the other.
Okay. Let's try and do it kind of in a logical way. What's the distance from here to here?
7 pi over 16.
7 pi over 16. What is the distance from here to here?
Negative pi over 16.
Yes, but as a distance pi over 16. So I have 7 pi over 16s here, and I have an additional 1 pi over 16. That's 8 pi over 16, right?
So
I'm talking about a distance. Look, it's like this. If I give you a number line, and I say, hey, look, what's the difference between -1 and 7? What's the distance there? Right? Here's 0. You would say from 0 to here is what? 7, and distance from here to here is 1. Right? So distance between these two is 8. That's what I'm trying to get you to see here. From here to here is 7 pi over 16. From here to here is another pi over 16. That's 8 pi over 16s. 8 pi over 16 is? Pi over 2. Pi over 2? Yes? Okay, what I was getting back with the formula is that it's 2 pi over this number. 4.
So if there's no number there,
It's 1, that would be 2 pi. The answer is pi over 2. All right.
I was so confused.
Phase shift. How do you get, what was the formula for phase shift?
Pi over 4 over 4.
It's this number over
4.
that number. This number over that number. So pi over 4 over 4. And if you reciprocate, you get pi over 16.
Did you say it was the opposite?
The negative. I don't care about the positive or negative. I really don't. Yeah, you're supposed to take the opposite of this and make it negative, but phase shift, that's just telling how much you moved by, right? Pi over 16? Yes.
Look at it like from 0 to where
Exactly. That's why I like the graph, because everything's here, right? All we did was took the sine curve, went this way, right? By pi over 16. So I don't normally like to ask these questions on a test because the picture includes all of that information if you know what you're looking at, right? But I'll ask them if you want. If you think this is easy to do, you get more points, you know? Like if this is all worth 10 points, this is worth 8 and this is worth 2, you know, that's almost like a free 2 points.
So is that
Well,
optional?
isn't
or-
Is that what?
Like, is it optional, like, you're gonna put it, or?
Do y'all want me to ask you all those things? Or do you just want to graph these? How many of you just want the graph? All right, we'll just do the graph. Okay. That was the majority.
But there was I was going over some of the homework the other day, and there was some like word problems that say using just they give you just the amplitude and the phase shift and the period.
And come up with the
And you have
function.
to come up with the function and stuff.
Yeah,
That's-
there was some like that on the homework.
Yeah.
Yeah.
So like there would be times when these formulas would help us.
That would be useful, yes. Okay, we only have 8 minutes. We have what? Anything from your homework is fair game. I mean, anything. I was looking at chapter review and I'm looking at what to me is like important. That problem right there that's an important problem. And then there's problems with tangent, graphing tangent and cotangent. The main reason I would ask you about tangent and cotangent is you have to set the argument equal to 2 different things. So for cotangent, it's, for tangent, it's negative pi over 2, pi over 2,
And cotangent 0.
0 and pi, right? So those, you need to know the difference. What else? Graphs. How about the inverse stuff? Inverse stuff. Yeah.
That one.
So something like again, I'm just kind of looking at something that just kind of popping out at me. What's that?
Is this something is between the sevens, right?
Yeah, we're in the eights now. I don't have much time. That's why I'm just kind of looking at what. Arc sine of negative 3 pi over 4. While you're looking at that, you got to be able to recognize the difference between something like that and something like this. And then something like this. Just take a look at the difference between all those problems. How do I do this one? How do I do this one?
The sine of negative 3 pi over 4.
So can I just like cancel these things out? Like arc sine and sine cancel, the answer is negative 3 pi over 4?
No, that's
That's dangerous. The only way that that's going to be true is if you are very clear on what the domain of this is and you realize whether or not that lies within that domain. And if you don't know that, then you just work it out real quick. What is sine of negative 3 pi over 4? Well, that's the y-coordinate at the angle negative 3 pi over 4. So here's negative pi over 4, negative 2 pi over 4, negative 3 pi over 4. So here's where you are. And you want the y-coordinate. So that is negative root 2 over 2. Right? That's the y-coordinate. So this becomes arc sine of negative root 2 over 2. Yeah, now you have to just completely forget all this ever happened and say to yourself, where is the y-coordinate? At what angle is the y-coordinate negative root 2 over 2? However, because I'm doing arc sine, I can only look where? On the right side, between negative pi over 2 and pi over 2. So where is that happening? Where's your y-coordinate? It's at there. Oh, be careful. That angle, that's right. So you got to go negative pi over 4. Right? You cannot come all the way around. So the answer to this is negative pi over 4. That make sense? All right, now this one. This one, let's try and just work it the same way. Can you figure out what this is? That is saying, is that giving me a number or an angle? That inside part. This should spit out what? A number or an angle? An angle. Okay, so that's saying at what angle on the unit circle is the y-coordinate negative 1/2? Y-coordinate because it's sine, right? So that is, at what angle is your y-coordinate negative 1/2? And I can only look on the right side because it's arc sine. Negative pi over 6, okay? That's where it happens. So this is negative pi over 6. So you're going to be taking tangent of negative pi over 6. So let me write this point down. This point was root 3 over 2, negative 1/2. So what is tangent of this? So you're going to go y over x. So negative 1/2 over root 3 over 2, and then reciprocate it. So you get negative 1 over root 3 when you flip it. And you can just leave it like that. Does that one make sense? This one, Tangent of negative pi over 4. So you go to negative pi over 4. Here, what's tangent of that angle? Close. I heard 1. Negative 1, right? Because the coordinates of this point are root 2 over 2, negative root 2 over 2. Tangent of that angle is the y over x. So this right here is negative 1, right? Negative 1. And so what we're really asking here is what is cosine inverse of negative 1? So that is saying at what angle is the x-coordinate negative 1 on the unit circle? But you're only allowed to look where? 0 to pi, which is just going to be pi. One more. I know we're out of time, but I just thought of this being a problem that you could see. How about something like, what's cotangent of arc sine of 7/9? With no calculator. That's not a common value, is it? You're saying where on your unit circle is your y-coordinate negative 7/9? I'm 7/9. You know what? Let's make it negative, just for fun. Let's make it negative. So where is your y-coordinate negative 7/9? But you're only allowed to look in these two quadrants because it's arc sine. Do you remember what to do here? Triangle, good. Now which quadrant am I going to draw my triangle in? Did I say that you can only be in the first and second quadrant? I think I did. I meant to say first and fourth. Okay. I've got to be in the fourth because sine is negative, we're down. So you would draw like a triangle like this, you know, right triangle, whatever. And then can I label any of those sides? Yes. Sine is opposite over hypotenuse. So this is 9. And this is negative 7, isn't it? Because the y-coordinate comes down. And then you can get this one right here. Pythagorean? Why would I want this one? Because I want cotangent of that angle. So cotangent is going to be this side over this side. So Pythagorean, I don't know what that is. Square root of 81 minus 49, whatever that is. Is that 32? Root 32? So what is the answer to this? Cotangent is adjacent over opposite. This is the adjacent, this side, and this is the opposite. So you should go root 32 over negative 7. Yes?
So you will make a triangle whenever you have the inverse sides of the
You don't what?
Like you go on a triangle whenever you have.
Inverse in here, and this is not something that you know. See over here, we had the inverse inside, but negative 1/2 was a common value on our unit circle, so I knew that that happened at negative pi over 6. When you have negative 7/9, that's not a common value, so you have to go to a triangle. Make sense?
For 8.3, are you going to want that
On this, the binder 8.3, no, 8.3 is the equation stuff, right? No, when you bring your binder, just have the homework for the sections that the test is over. And on the identities, I mean, I know that's like hours and hours of homework. Just do whatever you have, right? There will be identities on the test. I'll have a few. I'll probably have some easier ones than something a little bit harder. All right, good luck. You have like 46 hours to get ready. It's plenty of time. Get a lot done in 46 hours.